estimate the area under a curve. We have a bunch of table value. Each pair represents a point. So when the first pair is when x is 0, y is equals to 5, and then the next point is when x is equals to 1, y is equals to 16. I have 13 points. I plot all the points, connect them, I get a graph. The question that I am trying to answer is, what is the area under this curve? So you have a curve. I am looking for the area under this curve. So this is a curve, not a straight line. So you cannot we can treat that as a triangle and then try to find the area of the triangle. Now, there is a better way to do it. So first of all, I would like to use a method called left sum, and I want to divide the area under the curve into 6 subintervals. In other words, for subinterval is for subdivision. So subdivision, subinterval, they are the same thing. What did I say? Left sum 6 subintervals. So we are going from left to right, and then do not count the last value on the right end. So here is the way to do it. We are trying to build rectangles under the curve. So we are trying to build rectangle. So how do we build rectangle? How do we start? So from left to right. So first of all, let's do some math. So the first thing first is we want to find the width of a rectangle. So that is called delta x. So let's write this down. So we have delta x. What is that equal to? Delta x is equals to, you have to look at the domain. We are looking for the maximum value, which is 12, minus the minimum value, 0. And then how many intervals do you want? You want 6 intervals, right? So you divide it by 6 intervals. What is that equal to? 12 divided by 6 is equals to 2. So what is 2 represents? 2 represents delta x, which is the width or the base of each rectangle. So the width or the base of each rectangle is 2 units. So the way we do this is left sum. We go from left to right. So what is the first value you have on the left? 0. And then the next value is 2, right? So to make this super clear, I am going to draw a line that looks like this. So I'm going to draw a dot and then draw a line that looks like this. So the first x value is 0, and then 0 plus 2, that is equals to 2. 2 plus 2, 4 plus 2, 6 plus 2, 8 plus 2, and then 10 plus 2. So we start at 12, and then let's draw a dot, and then we erase the leftover. All right, so and then we erase the leftover. So how many intervals do you see? I see that there is 1, 2, 3, 4, 5, 6. 6 interval. Each interval is 2 units long. And then you start at 0. So when x is equals to 0, we have this point, and then we draw a line to the right from left to right, and then it's 2 units, right? So we draw a line that is 2 units long, and then we connect the bottom. All right, and then when x is equals to 2, y is equals to this, and then we draw a straight line and then connect that to the bottom. When x is 2 units, 2 units, so the straight line is supposed to be from 2 to 4, and then we connect that to the bottom. When x is equals to 4, we have this point, and then we draw a straight line from 4 to 6, and then connect that to the bottom. And then when x is equals to 6, y is equals to this, and then we draw a straight line that is 2 units long from 6 to 8, and then we connect the 8. When x is equals to 8, we have this y value, and then we draw a line that is 2 units long, extend all the way to 10, and then we connect to the bottom. And then when x is equals to 10, we draw a straight line. We started at 10. When x is equals to 10, y is equals to that, 2 units long, and then we connect to the bottom. And then to get the triangle, I will just connect the rest. Do you see that we have 6 triangles now? Do you see that? 6 triangles. So we have 1, 2, 3, 4, 5, 6. So we have 6 triangles. Let's read this sentence one more time because that is way too important. We go from left to right, and do not count the last value on the right end. What is the last value on the right end? We go from 0 and then we make 2 steps at a time. The last value is 12. We do not count the 12 because if you consider when x is equals to 12, yes, that is a point. But if when you extend 2 units to the right, from left to right, there is nothing on the right hand side of 12 because the domain is from 0 to 12. That's why for the left sum, we do not count the 12. All right. Now, how do we find the area? How do we find the area under a curve? So to find the area under the curve, so what we are doing is we are looking for the area of each of the rectangle and then we add them. So we have 6 rectangle. That means we have to calculate 6 areas and then we add them up. Then that is the estimation of the area under the curve. Yes, we are going to miss a little bit. So we are going to miss this. Do you see that every rectangle has a little bit, has like a corner on top of each rectangle? We are going to miss those areas. It is okay because we are doing an estimation. Now, the next question is, how do you find the area of a rectangle? The area of each of these rectangle is base times height, right? So the base times height. So we are going to do this. So left sum n equals to 6. So we are going to write L6, that is left sum, using 6 intervals. And then for the first rectangle, we have the delta x, which is 2, right? Times the height. What is the height of the first rectangle? How do you measure the height? To measure the height, you have to tell me what this, how tall is this y value. How do you measure the height? The height is when x is equals to 0, y is equals to 5. So we have to write 2 times f of 0, which is equals to 5. And then the next rectangle is 2. And then the height, what is the height? How tall is this? That is f of 2, right? So when x is equals to 2, y is equals to 27. Let's just write f of 2 right now, and then I will do the plug-in. And then f of 2, and then we have the next rectangle, which is the base, times f of 4, right? F of 4 is right over here, and this is the height of the rectangle. When x is equals to 4, we know what the height is. And then plus 2 f of 6, and then plus 2 times f of 8, and then plus 2 times f of 10. And then we do not count the 12. So do not count f of 12. Do not count the 12 because we already have 6 rectangles. Let's count. 1, 2, 3, 4, 5, 6. We already have 6 rectangles. And then the way that every textbook write is they will just factor out the 2. So the way they do this is they will just do L6 and then 2, and then they put everything in a square bracket to put this in a more compact form. So let me quickly write that for you. F of 0, f of 2, and then f of 4, f of 6, and then f of 8, and then f of 10. That is how every single book write this. And then you have to tell me what the y values is. So L6, so that is 2. When x is equals to 0, you have to use the table. Oh, by the way, I suggest you to copy this table right now so you don't need to go rewind back and forth in my video. So just write this down or take a screenshot of that. Take a screenshot of the table value. So when x is equals to 0, y is equals to 5, right? And then when x is equals to 2, y is equals to 27, and then x equals to 4, y equals to 43, so on and so forth. You have to take the 50, the 54, and the 57. We are going to take all these values. So let me get rid of this circle so that won't make my notes too messy. And then plus 27, f of 4, that is 43, f of 6, that is 50, f of 8, that is 54, and then f of 10, that is 57. And then that is equals to 2. What is the sum? The sum is 236, and then 2 times that, that is 472. And then this is the area under the curve using left sum, 6 subinterval, or 6 subdivision. All right, so that is L6. And then how about the right sum? The right sum, we will go from right to left, and then we do not count the last value. So for the right sum, I am going to do the same things. So we are going to find the width, the base of the rectangle, that is the maximum, minus the minimum x, and then divided by 6 intervals, right? that is equals to 2, and then this is the base or the width of the rectangle. And then the interval, so we go from 0 all the way to 12, right? So 0 plus 2, 2 plus 2, 4 plus 2, 6 plus 2, 8 plus 2, and then 10 plus 2, we stop at 12. And then please count that we have 6 subinterval, right? 6 subinterval. Do you see that? 6 subinterval. And then for the R6, we will be taking the delta x, which is 2 times 1. Now, let's draw the rectangle. So we go from right to left. The first one on the right is 12. So we will be taking the 12, 10, 8, 6, 4, 2, and then ignore the 0. Let's do that. So when x is equals to 12, we have this point, and then 2 units from 12 to 10. And then you line up the 10. That is your first rectangle. And then when x is equals to 10, you are at this point from 10 to 8. Straight line, and then you line up the 8. And then when x is equals to 8, we have this point from 8 to 6. Line up the 6. When x is equals to 6, we have this point from 6 to 4, and then you line up the 4. And then when x is equals to 4, we have this point from 4 to 2. We line up the 2. When x is equals to 2, the line doesn't go straight. I want the line straight. Okay, let's redo it to 2. Line up with the 2. Let's make it perfect. To 2, and then we line up with 2. And then when x is equals to 2, we start at this point, and then we reach the 0, and then we line up with the 0. How many rectangles do you see? We have 1, 2, 3, 4, 5, 6 rectangle, 6 subinterval, 6 subdivisions, whatever you like to call. And then you find the area of each rectangle, and then you add them up. The base is always 2, right? So we can just factor out the 2. And then from right to left, we have f of 12. And then we have f of 10. And then we have f of 8. And then we have f of 6. And then we have f of 4. And then we have f of 2, and then we do not count the 0. Take a look, how many y's do we have? 1, 2, 3, 4, 5, 6. We already have 6. We do not need the 0. In fact, if you take the 0, listen to me right now. If you take the 0 and then you go 2 units to the right, you are out of the chart. There is nothing on the left-hand side of 0. That's why we do not take the 0. Let's just count this. Do not count f of 0. Okay, let's take a look at what that equals to. So we have 2 times, when x is equals to 12, you have to grab this value, right? 65, 57, 54, 50, 43, and 27. All right, you got that? So let's get rid of this circle. Otherwise, the notes will look very messy. And then I will just bring this down. So we have a 65, 57, 54, 50, 43, and 27. So 2 times, add them up, that is a 296, and then you multiply, the area is equals to 952. So this is area. Now let's compare the left and right. The left is 472, the right is 592. Which one is underestimate? So if you take a look at the left, do you see that every time we make a rectangle, we miss some area on the top, right? So this one, the left sum, is definitely an underestimate. Is the left sum always underestimate? The answer is no. If this is an increasing function, if the function is a decreasing function, I am pretty sure the left sum will be an overestimate. So it is not always. You have to check out the graph. Or you find the left sum and the right sum and compare which one is big and which one is small. For the right sum, every time we construct a rectangle, we always overestimate a little bit. So therefore, the right sum is an overestimation. All right, and then we have 472 and 592s. Now, The next question that I would like to answer is, hey, what if I want to divide this into a 4 subintervals or even a 2 subinterval? How does that change the answer? Well, let's answer that right now. So here, 4 subintervals, left sum, and 4 subinterval right sum. Let's do it. Okay, let's follow the color code. So I am going to do a delta x that is equals to maximum minus minimum divided by 4 intervals, right? So which is equals to 12 divided by 4, that is equals to 3, so that is the width. And then from left to right, I have a 0, and then all the way to 12, right? So we have a 0 plus 3, 3 plus 3, 6 plus 3, and then 9 plus 3, and then the 12, let's use a dot, so that is the end of the interval. So now we have 4 intervals, right? You can count, that is 1, 2, 3, and 4. So we have 4 subintervals, and then we move on to the graph from left to right. So 0, we go 3 units, right? Did I move this up? Okay. Does that mess up anything? You know what? I will just let's see. What happen if I move this down? No, the 5 will just move to a 0. I guess I will just have to do it like this. Yeah, I guess I will have to do it like this. Something must gone wrong when I was doing the copy and paste. Okay. When x is equals to 0, we have this. When x is equals to 0. And then we go from 0 to 3. So now we have a rectangle. And then from when x is equals to 3, we have right here, right? And then from 3 to 6, we have a straight line, and then we line up with the 6. And then when x is equals to 6, we have this point from 6 to 9. This is 3 units, and then we line up the line. Alright, when x is equals to 9, we have this, and then we go all the way to 12, and then we line up with the 12, and then we do not consider f of 12. So we only consider 0, 3, 6, 9. We grab 4 numbers from left to right. Alright, and then we complete the rectangle. So each of this rectangle, we have to calculate the area. So what is the area? The area, so this is L4, right? So that is delta x equals to f of 0 plus f of 3 plus f of 6 and then plus f of 9. We do not count the 12, so do not count f of 12. Okay, now L4. So 3, for the table value, you have to grab that all the way from the beginning. Do you see the table value up there? Write this down or take a screenshot of that. I will just give you those values. So for this L4, then you have an x is equals to 0, you have a 5, x equals to 3, x equals to 6, x equals to 9. So you have all that. So L4, that is equals to 3 times 145, that is equals to 435. So that is equals to 435, and then this is the estimated area. So how about right sum? From right sum, so we will go from right to left. So this time we will be going from 4, right? So let's change the color. So we will check the 12, 9, 6, and 3 from right to left. How about this? I am going to copy and paste. So I'm going to copy this and then paste right here, and then erase the extra stuff. So from right to left, so we will be taking the 12, 9, 6, and 3, and then we omit the 0. So from 12, we have a point right over here, and then we go extend a straight line to 9. And then we, the 9. To 9, which is right. I think this is a little bit off. Is that true? Yep, that's why they don't really match. Okay, let's see what happens if we do this. If we move this a little bit, does that help? I think that one is better. Yep. So from 12 and then you go all the way to 9 and then you line up with the 9 and then when x is equals to 9 and then from 9 to 6 we go all the way to 6 and then we line up with the 6 and then when x is equals to 6 we start at 6 and then we line up the 3 and then connect that, and when x is equals to 3, I know that is a little bit off, but it is not that hard to see. Connect with, go to the 0 and then connect the 0. Alright, so this is a right sum from right to left, and then this is a R4 equals to, the width is still 3, and then we have f of 12 plus f of 9 plus f of 6 plus f of 3. So take the table value I gave you. X is equals to 12, we have 65. X equals to 9, we have 55. X equals to 6, we have a 50. X equals to 3, we have a 35. And then R4, that is equals to 3 times 205. That is equals to 615. So this is the area. And then let's try two intervals. What happened when we use two intervals? So when we have two intervals, this is going to be easier, but will be a less accurate because we will have a lot of overestimate and underestimate. So when x is equals to 2, let's change the color. So we have delta x equals to 12 minus 0 and then divided by two intervals. So we have each interval, the width is equals to 6. And then from left to right, we have a 0. And then we have a 6. And then we have a 12. So two intervals. And then from 0 to 6, we will have this. So from 0 to 6, right here. And then when x is equals to 6, we have this point. And then we extend all the way to 12. And then we have that. So these are the two rectangles. Let's find the area. So the area L2, that is equals to delta x times f of 0 plus f of 6. We do not count the 12 because when you start at 12, there is nothing on the right hand side. Okay, so that is 6 times f of 0. So that is 5 plus 50. The area is equals to 330. So that one is an area. And then for R2, so we are going to do a copy and paste technique. So we are going to do a copy and then paste. So for right sum, what we are taking is, we will be taking from right to left. That's all we have to take. So we have a R2 that is equals to delta x times f of 12 plus f of 6. That's it. So f of 12, we have that right over here. And then we extend this to 6. So extend this all the way to 6. And then we line up with the 6. And then from 6, we have that. And then we extend all the way to 0. And then we line up with a 0. So these are the two huge rectangles. So that is equals to 6. X equals to 12. We have 65. X equals to 6. We have a 50. So that is equals to 690. So this is your area. So how many subinterval is enough? The answer is use as many as possible. Do you see that when we have two subinterval, we have a lot of overestimate and then a lot of underestimate, right? But if we compare the 2 and the 10, do we agree that if we go back to a 10 interval, this little area is so much smaller, right? So that means if you are using like 100 intervals or 1,000 interval, the estimation will be more accurate. But there is a trade-off. Yes, the estimation is more accurate. This little corner will be very, very small, but you will have a lot of work to do. So the answer is using as many subintervals as possible. but the work will be tough because you have to deal using 1000 intervals. You have a lot of numbers to add. That's the idea. Okay, let's jump to a conclusion for everything we did. So for a conclusion, to be honest, there is no need to sketch the graph. So when you do the left sum, do not count the y value on the right end. For the right sum, you do not count the y value on the left end. So what that means is, for the left sum, you only have to grab everything up to the second from the last x value. So two intervals, right? So you go from left to right, you pick everything except the last one. The right sum, you go from right to left, you pick everything except the last number on the left. That is not that difficult to memorize, right? Left to right, grab everything except the last one on the right. Right sum, from right to left, you grab everything on the right except the very last value on the left. All right, and then, like, for example, let's say we have a table value like this. You don't even need to sketch the graph. And then let's suppose that we are using 5 subintervals, and then delta x is equals to 1. And then for left sum, using 5 intervals, so all we have to do is we will be using a f of 1 plus f of 2 plus f of 3 plus f of 4 and then plus f of 5. And then for the right sum, we will go from right to left, so from 6, and then we go all the way and stop at 2. F of 5, and then f of 4, f of 3, and then f of 2. We do not take the last value because we already have 5 intervals, right? So we already have 5 intervals and 5 rectangles. There is no need to take the last one. So what about another what if? What if you don't even have the table value? You have a function. So your function is given instead of the table value. That is even easier. You don't need to count on the table at all. All you have to do is you plug in x to the function to obtain the corresponding y value. And then the y value is equals to the height of the rectangle. What the rectangle of what? The rectangle under the graph of f of x. So for this one, let's say I cover up the entire table value. I give you a function. So let's say f of x equals to x squared. So to obtain the y value, all you have to do is you plug in the x value to the function. The x value is always given because they will have to give you the domain, right? So you take for the domain, you take the maximum minus minimum divided by the number of subinterval. That gives you the cut on the x value, on the x-axis. All right, so that is the end of this video. I think that this video saved you a lot of time from reading the book, because the book usually they put this in a very complicated format. All right, if you like it, give me a like, share, and subscribe, and I will catch you all in the next one. Signing out.